Assalamu alaikum everybody. I hope you all are doing well and I am audible. Walaikum assalam, walaikum assalam. How is everybody doing? I hope you all are doing super duper well. Am I audible? Assalamu alaikum everybody. Kindly let me know in the chat box. Let me set up my phone on the side so that I could see your messages and then we can jump on to today's content inshallah. So let me just send the link and everything in the group that we are starting off. Walaikum assalam everybody. So the goal for today is to basically cover up some topicals from chapter number 2 and chapter number 3 inshallah. We're going to try to cover them in great detail. We're going to try to see everything that's there in our syllabus inshallah, and we're going to do chapter number 3 in 2 parts inshallah, just because I know that it has this one problem. People think that we can cover up the entire chapter number 3 in just like 4 or 5 questions, but no, the chapter number 3 is basically 3 big topics, right? So it's important that we cover it up in great detail inshallah. So let me just put up a story that if anybody wants to join in, they can just join in right now. So we are live. Just give me a second. आवाज़ ऊंची करूँ? आवाज़ अभी भी ऊंची होगी आई गेस. हेलो, हाँ ऊंची है सही है. So just give me 1 second. Let me just put up this story. We are live so that if anybody wants to join in, they can. And Baki, if you guys want to share the link with your friends, kar lo, so that they don't miss upon anything. Okay. Let me send it even up here. Past paper session. वैसे आप लोग अपने स्पीकर्स चेक कर लो. लिंक सही आ रही है. सर प्लीज़ रिवीजन ऑफ चैप्टर 3 फर्स्ट. भाई आप ज़रा चैनल तो देख लो. कल पिछले 2 दिनों से यही तो करा रहा हूँ. चैप्टर 3 की रिवीजन हो गई है. Alright, let's just start off without wasting any further time. The goal for today is to basically cover up some topical questions from chapter number 2, chapter number 3 inshallah. We're going to do as many questions as possible. The class will be of inshallah 2 hours. Will you also do for papers 2? Yes, paper 2 होगा inshallah. सर आपकी आवाज़ एक एयरबड से कम आ रही है. ये तो अजीब सा सवाल है. आपके एयरबड में तो कोई मसला नहीं हो गया बिकॉज इट सीम्स परफेक्टली फाइन अप हियर. यहाँ पे फ़ोन पे भी चेक कर लेता हूँ. नहीं परफेक्ट है. एवरीथिंग इज़ गुड. सही है. या इट्स परफेक्ट. ऑलराइट, लेट्स देन जस्ट स्टार्ट ऑफ. सही है. विदाउट वेस्टिंग एनी फर्दर टाइम, I'm gonna just start the screen sharing, and I hope you guys can then see the screen. Just give me a second. So window capture and open up the notes taking app. Where is it? Yep. Alright, I hope you guys can see the screen. Let me have a look. Yep, it's clearly audible. Same. Sir, alhamdulillah, topicals हो गए हैं. I would still recommend doing topicals. Kursim, there will be an issue most probably at your end. Try to see if the speaker is on or not. There might be a problem up there. But yeah, try to practice as many questions in these days as possible. It's really important that the more questions you practice, the better your performance is going to be, inshallah. And let's start off. Okay? Bismillahirrahmanirrahim. So here's my graphic pen. Pen. Wow, so I lost my pen. Okay, it's up here. Move your mic a bit close and oh bhai ऐसे नहीं होता. Most probably turn it to a speaker or maybe check it on your phone. Speaker सही है. Guys, आप earbuds के बगैर check कर लो. ऐसे given low sound in the left. That's something अजीब. By the way, this shouldn't be happening though. Let me have a check at the settings. Maybe left, right, it's equal. यार equal ही है guys. आप लोग चेक कर लो. ट्राई टू ज्वाइन इन फ्रॉम फ़ोन एंड फ़ोन के स्पीकर से देखना. आई गेस मसला तो होना नहीं चाहिए. आई इवन चेक्ड इट फ्रॉम माई अदर डिवाइस and the voice is perfectly fine. So we will be basically doing chapter number 2 and plus chapter number 3.1 topicals today inshallah. Tomorrow our aim is to do chapter number 3.2, 3.3 and 3.4 topicals alongside chapter number 4, and then we can see what to do next. हाँ सही है रोहान. The volume is perfectly fine. Okay, so we're gonna start off with the 2024 session. I'm gonna put some questions first. We're gonna try to see what they are asking, how do we solve those questions, and within this we are also gonna recap the whole concept. Okay, so let me just open up some paper and we're gonna grab some questions from topic number 2. So let me just open up a paper and grab some questions from it. So first and foremost question will be, let me find a question. Yeah, that's a really good question. So we just found this one question from chapter number 2, which talks about data packets. So a very good start to the topic, because this is of course just a basic introduction to chapter number 2. So we need to describe the structure of a data packet, and that we need to explain stuff about it. Okay, so the question says that data packets are basically transmitted across a network from one computer to another. Okay, then it says describe the structure of a data packet. So we all know what a data packet is, right? When we are transmitting data, we convert that whole set of data into smaller chunks. Every smaller chunk is basically known as a packet. And a packet is basically divided into 3 different sections. So this question asks you to basically discuss those 3 sections. So you're going to talk about how a packet is divided into 3 sections, Okay, the first section is basically known as 3 sections. The first section is a header. The second section is payload, and the third one is trailer. The second one is payload, and the last one, or the third one, payload, and the third one is a trailer. Now you should know that when we talk about header, the header basically stores data regarding the address of the receiver, the address of the person to which you are sending. It's going to store the total number of packets, details such as that. Payload basically stores the actual data which is inside the packet, so the data that is being transmitted. Okay, whereas the third one, which is the trailer basically stores some sort of error detection method to ensure that when the packet goes to the receiver, it could be checked whether that packet is transmitted correctly or not. So we can say that when we calculate the value of checksum, we say that checksum is transmitted alongside the file, the value. So the value of checksum is then basically stored within the trailer. Okay, so not the discriminant, it is only the derivative. Yep. So if this question was a 6-marker question, then you would have been required to write header followed by this explanation that header basically stores this. Then payload, what is payload? You need to explain that. What is trailer? You need to explain that. But because this is only a 3-marker question, they are only expecting you to talk about the fact that there are going to be 3 sections. One is going to be header, the other is going to be payload, and the third one is going to be trailer. So always look on to the number of marks, and based upon that try to answer it up. Perfect. Let's move on. Part B now says packet switching is used to transmit the data packets across the network. Identify the device which controls the path. So remember that whenever we have a packet, the path of the packet, or like in what direction it has to move, when will it move that way, which one is the fastest, all such things are basically determined by something we call as a router. Okay, so you need to write the word router clear cut up here and you're going to get marks. Part C now says that serial data transmission एक तो गला को क्या हो गया पता नहीं. Sir, haven't you already solved? पता नहीं, I'm not sure though. लाइन्स कंप्लीट करने की ज़रूरत नहीं भाई, ये किसने बोला? कोई लाइन कंप्लीट करने की ज़रूरत नहीं होती. सही है, पता नहीं अगर आपको किसी ने बताया लाइन्स पे नंबर नहीं मिलते, पॉइंट्स पे मिलते हैं. सो इफ़ यू रोड 3 पॉइंट्स अकॉर्डिंग टू द मार्किंग स्कीम आपको मिल जाएंगे, चाहे 2 लाइन के अंदर ही हो. दिस इज़ द 2024 पेपर. ओके, So Batsina says serial data transmission is used to transmit the data packets across the network. Explain why serial data transmission is used to transmit the data packets. 3 marker, which means that you need to write 3 points. My recommendation would be when the question does not specifically ask how many points to write, and if you know something like 4 points, it's better to go with 1 extra point, so that if any other point is a bit vague or a weak point, you're still good to go. So the question asks you, why should they go with serial data transmission? So serial data transmission, also another important point is that they make use of the keyword explain. The explain keyword is really important. People usually don't understand this. Explain basically means that you write a point and then you explain, or like you reason it up, that why this point or what does that mean. So whenever a question asks you to explain something, you basically need to write 1 point followed by its explanation, then another point followed by its explanation. So why should one be going with serial data transmission? So we can say that maybe the network which we have at this point, it might be over a long distance, it may be spread over a long distance, and so like when we make use of serial transmission, it is more reliable. Why? Because bits will be arriving in a sequence, so it's less likely for the bits to be skewed, and there is also less chance for there to be any sort of interference, so that errors are caused. So we're going to write all these points. So I can say that the network the network may be spread over a long distance, may be spread over a long distance, and hence serial transmission will be more reliable, will be more reliable. That's the first point. So in this, if you see, this is the point that's spread over a longer distance, and then that's the explanation that okay, because it's going to be spread over longer distance, serial transmission is going to be more reliable. Why is it going to be more reliable? Because definitely now you come to the second point where you say that because the bits will arrive in a sequence. This is because bits will arrive in a sequence, and hence the data will not be skewed. Skewed, in other words, means that being out of order, okay, would not be skewed. So if you also talk about this point, you can clearly see one point is that you talk about that it's arriving in a sequence, and if it's arriving in a sequence, what's the second point? Is that when it arrives in a sequence, the data will not be skewed. So that's your second point. If you write this, you're going to get 4 by 4, okay? In this case, you're going to get 3 by 3. If you want to write more, you can also say that there will be less interference because the data is only going in on a single wire, right? On a single wire. So because data is only going on a single wire, there will be less interference in comparison to if we had like a parallel one where we had multiple wires together. You're going to say that there will be less interference, and therefore the chances of errors will be low. So this answer which I just wrote, this is basically an answer you need to write if this question was of 6 marks. So I just wrote 3 points plus 3 explanation, and I'm going to get basically 6 by 6 for writing such an answer if the question asks. In this question, you are just required to write 3 points. So even if you write the explanation for any 2 of them, and then you would be good to go. Sir, can we write low cost? No, you cannot write low cost. That would be incorrect, because low cost does not show anything specific as to why you might be transmitting the data packets over a network, okay, over a long network. So you need to be very specific to why we need to make use of serial transmission. Alright. We finished 3 chapters in 2 days. I will not be doing the revision sessions for the other 4 topics. For everything else, you're going to do the topicals. So you're going to do topicals for chapter 2 plus 3.1, 3.2 today. That is like the 10th. Tomorrow we are going to do chapter number 3 entirely. So 3.3, 3.4 plus chapter number 4. That's the 11th. And then on the 12th, I'm going to do chapter number 5 and chapter number 6. Okay. That's the overall plan to it. But yeah, let's see. I was thinking of conducting a chapter number 6 recap session, but that is something we're gonna think after it over times. Okay. Sir, I wrote it works well over longer distance, and it occurs when data is sent only 1 bit at a time and ensures fully synchronized. So you're just gonna get 2 marks in this. You know why? One is that you said that it's gonna work well over longer distances. So you don't say that it works well. The question says why they might have used it. So you can say that okay, they might have used this because the distance is very large, or like this network would have been over a very longer distance, and so if the bits arrive at once, the data will be fully synchronized. So you just wrote 1 point followed by its explanation, so this will get you 2 out of 3 marks. Okay, so the answer must be related to reasoning behind why serial data transmission is used, rather than just asking about the benefits of serial data transmission. So read the question really careful. Okay. Alright, let's move on. So, sir, if we write 1 point and explain it, then state only 1 word, will we get 3 marks? Yes, you're going to get 3 marks then. You're going to get 3 marks. Alright, let me find some other questions. So, this was a good question, starting question for the content. And let's now just move on. So, now we're going to do this question which is related to encryption. Okay, this is a really good question. Encryption is one of the examiner's most favorite topic, and I hope you guys are clear with it, but if you aren't, don't worry. So we have 2 types of encryption in our syllabus. One is known as the symmetric one, the other is known as the asymmetric one. So the symmetric encryption is the one where you have a single key. So like if I have a code and software or like some key, that same key is used to encrypt a document, and then the same key is used to decrypt the document. But now the problem is that if I encrypt the document and I have to send the encrypted document to person B, if I'm person A, then I also need to send the key, because the same key would be used to decrypt the document. Now if a hacker somehow pops up out of nowhere up here and they try to get access to the data, in that case we will be cooked. Okay, because now he has the key, he has the file, he can decrypt it on his own. Then we have something known as an asymmetric encryption. What happens in asymmetric encryption is that we have 2 keys. One is the public key, the other is the private key. So when we have a public and private key, the private key is basically with the person who needs to send the data. So like if I'm person A, I need the data from person number B. So what I'm going to do is I'm going to generate a pair of keys. One is going to be the public key, which can only be used to encrypt the data, and then there will be something like the private key. The private key will only be used to decrypt it. So in asymmetric, public key is only used to encrypt, whereas the private key, that is only used to decrypt. So if I'm the user and I, let's say, want to get data from let's suppose Shahzaman. So Shahzaman is up here and I'm person A, Maz. Okay, so if I need the data and I need it from Shahzaman, what I'm going to do is I'm going to send my public key. So using the public key, which is openly available to anybody out there, Shahzaman is going to encrypt the file. Then he's going to send that encrypted file back to me. You cannot decrypt a file using the public key. You can only encrypt it. Now, when the file comes to me, I can decrypt it using my private key, which is only with me. No one has it. So even if a hacker gets access to the data, he cannot decrypt it because he does not have the private key, which makes asymmetric encryption more secure. So now this question asks you to basically explain this description. Okay, so the question says that dash is encrypted into dash using a dash. So remember, the document which is originally unencrypted, the one which has no encryption applied on it, that's known as plain text. Okay, so we say that plain text is basically converted into dash. So when you apply the key upon a plain text, when you apply a key upon the plain text, it makes it basically a ciphertext. So we say that plain text is basically encrypted into ciphertext, and this is basically done how? You make use of an encryption key. So you're gonna see, do we have a key up here? So done. Okay, so using a dash key. So I don't know what key needs to come up here, whether it should be, perhaps the question is about asymmetric. Okay, it does. It clearly tells us that it's about asymmetric encryption. So if it's asymmetric encryption, I know that we need to encrypt it using what? We need to encrypt it using the public key. Hence, the answer up here is going to be using a public key. And then we say that the encrypted data is then transmitted from the sender to the receiver, and then the encrypted data is decrypted using what? Using my private key. So there's my private key. So I'm going to just write private key up here, and boom, that is the question you should know. So in exam, you might also get a question upon asking you what are the differences between public and private, or symmetric and asymmetric encryption. So remember, one difference is that asymmetric encryption uses 2 keys rather than just 1 key, and another difference is that in symmetric encryption you use the same key to both encrypt and decrypt, whereas in the asymmetric one you use the public key to encrypt it and you use the private key to decrypt it. Then the third one, you can also say that in asymmetric, the private key only stays with the user to which the data is being sent, whereas public key is openly available, whereas in symmetric encryption, the public key is sent to the user to both encrypt and decrypt it. So you can discuss all of these points. Symmetric encryption only has single key. Symmetric encryption only has a public key. Symmetric encryption has just one key. It does not have like public or private. The same keys to use to encrypt and decrypt. So you don't have to openly share it. जिस बंदे को आप डेटा भेज रहे हो उसी बंदे को आप ये की भी दे रहे हो कि यार इसी के साथ आप हैक कर इसको decrypt कर लो. Okay, and that is the whole concept regarding symmetric encryption. All right, perfect. Let's move on to a next question. Okay, so yep, symmetric encryption is way more secure. Why is it more secure? It's more secure because of the fact that when we have symmetric encryption, you have two keys. So these two keys basically allows us to make the whole system way more secure. Okay. Alright, let's do this second question, and this will further clarify your concepts in regards to symmetric encryption, so that if anybody is still not clear upon it, don't worry, we're gonna do it. Okay, so this question says that data can be transmitted from one device to another. You need to tick one box to show which of the terms is not a method for transmitting data. Transmitting data. So in transmitting we have serial, that's correct. We have simplex Vitesse, we have parallel. What is parity? Now parity is not a method used for transmitting data. It's a method used for error detection. Because it's a method used for error detection, we can say that the answer to this is basically D. Part B now says that data is broken down into smaller units so that it could be transmitted from one device to another. Give the name of the unit that data is broken down into. Now what is that chunk to which the data is usually broken in? We just saw this, right? That whenever you have a large set of data, we divide that large data into smaller chunk known as packets. So therefore the answer to this is basically packet. So I'm just going to write packet up here. Moving on, the C part of this question again discusses the concept of what do we call not data packet, you just write packet. Okay, so C part of this question comes again regarding the concept of encryption, where it asks the student to explain that data is often encrypted when it is transmitted from one device to another. Explain how data is encrypted using symmetric encryption. So we need to explain the process of symmetric encryption. Now remember, in a symmetric encryption, data is encrypted and decrypted using the same key. Then the plain text is then encrypted into ciphertext using an algorithm that uses a key. The key can be generated using an algorithm, and the key is then sent to the receiver who then decrypts it. So I'm going to say the main point is symmetric encryption uses the same key to both encrypt and decrypt the file. That's my first point. Encrypt the file. Then you can explain how this works. So we're gonna say plain text is the one जिसके ऊपर अभी key नहीं applied, the one which does not have the key applied upon it. So plain text is converted into ciphertext, which is the one when you apply the key upon it using a key that has been generated using an algorithm. Okay, use the keyword algorithm, that's the keyword, don't write something like software. Okay, using an algorithm. And then you can say the key is then transmitted to the receiver to decrypt the file. Okay, decrypt the file. And that is how you basically answer this question. Okay, moving on, part 2 now of this question says that you need to explain the purpose of encryption. So the only purpose of encryption is to make the data meaningless. By making it meaningless, we can assume that even if a hacker gets access to the data, he or she will not be able to understand what's happening. So it's not going to make any sense to them. So this keeps our data more secure. So I can say to make the data meaningless, Okay, Shayan, do remind me once we are done, and then we can see. Okay, so that's one point. And you can also write the second point, which I've seen in marking schemes, which is that it helps you to make the data more secure. So you can say to help keep the data more secure. So because it was just a one marker question, you were just required to write one single statement. So 1 point and you're good to go. And this basically would explain how encryption works. Okay, let me see if I can have some other question for topic number 2 up here, so that we can do that. Otherwise we can move on. Okay, that is from chapter 3, so let's leave that for now. Okay, we do have a good question finally. So it's from the error detection method topic. So a 5 marker question, a pretty good question, and now let's try doing it. So it says that the table contains statements about error detection method. Okay, it says that you need to complete the table by giving the correct error detection method. So the first one says that it's an error detection method that makes use of an odd or even process. So we all know that the only error detection method that uses odd and even method is known as parity. So you can write parity. But now we have parity bits, we have parity block, we have parity check. What do I need to write? Just writing parity is wrong. So you need to write the full form. You can write parity bit, or you can write parity block, or you could write parity check. So whatever of these two, it's better to write one of these two. But yeah, whether you write parity bit or you write parity block, either of them are correct, but please do write the full form. Don't be the student who just writes parity and thinking that you'll be good. So write parity bit or parity block. Okay. Part 2 or the option number 2 says that the value is calculated from the data using an algorithm. This happens before and after the data is transmitted. So it's basically the description of checksum, where the data's a value is calculated using the data, and then that value is sent alongside the data to the transmitter, to the receiver, sorry, and then the receiver again recalculates the value using the same algorithm, and then the values are compared. If they are the same, you're good to go. If not, then there was an error. The third one says that a copy of the data is sent back to the sender by the receiver. So this one is basically echo check, where if let's say user A sends data back, sends data to user B is going to send the same data back to user A, and then user A would be like, okay, yes, I sent this data, this is the same as what I wanted to send, so good to go. If not, then they are going to send their data again. Point 4 says acknowledgement and timeout. These two are basically common features of a method known as automatic repeat query. Automatic repeat query, or in simple words you would have also studied it to be something like ARQ. So it's ARQ, where you send the data and then you basically have acknowledgement. If you do not get the acknowledgement within the specific timeout zone, it's a clear indicator that the data has been sent incorrectly. If a positive acknowledgement was sent, this means that the value was perfectly fine. So that's ARQ. And the last one is a bit confusing. It says that a value is appended to data that has been calculated using the data. This value is checked on data entry. Now the thing is, please understand that the question says two things. First, that the value is appended, and the secondly, the value is used on data entry. This was a question asked by a student that day. It said that the answer to this is, by the way, check digit. What is check digit? Check digit is basically that method in which what happens is, these are O-level questions too, so it's not only IGCSE. If you open O-level summer 24 question paper 12 and you check out the question number 6, it's the same. And even if you open up IGCSE summer 24 question paper 12 question number 6, it's the same thing. Okay, no, full forms are recommended. Okay, but even if you write ARQ, you can get marks, but better. Now one thing is, what's check digit? Check digit is that when you have some numbers, okay, so numbers 1 2 3 4 5 6 7, you basically use a formula to calculate one answer out of it. So let's say it might be something like 9, and then you write 9 next to it, similar to the ISBN numbers we have, similar to the barcodes we have and all that stuff. Okay, and this value is my check digit value. So now when you scan it up using a data entry point, or when you want to scan it using a barcode, what happens is they check this part and they recalculate the value. Then they compare whether this 9 is equal to this or not. If it is, then you're good to go. If not, then there would have been some error. Now remember, the steps behind this are not to be memorized. No modulo 11, no ISBN 11 method are to be memorized. If ever asked in exam, they are going to give you the steps. You're good to go. Okay, don't worry at all. But the point here to note is that your check digit only works on data entry. That's the really, really, really important point. Really important point. That day a student sent me a question where the question asked that the data is being transmitted from user A to user B. Okay, transmitted from user A to user B. And the question asks tell me the error detection method. So the student wrote about check digit. That's wrong. Why? Because check digit can only be used on data entry. Check digit is not able to confirm or verify transmission between two users. Okay, so you cannot basically use check digit for the purpose of ensuring that the data has been correctly sent from user A to user B. However, for that you can make use of something like checksum. So if the question asks you, that you need to basically check a value by using the data, you basically need to calculate the data, and then that data is sent alongside it, but it's not appended. If it's not appended to it, it's not like added to the actual data, then this means that they are talking about checksum. Okay, and especially when it's talking about the data transmission, it's checksum. But if the question says that the value is calculated and then that value is appended to the data, okay, so like you write it next to the data and it is used at a data entry point, then it has to be check digit. So this is what explains you this part. Sir, for the first one, do we write parity check or parity bit? You can write parity bit, you can write parity block, you can write parity check. All three of them are fine. So it's up to you, whatever you want to write. Okay. Moving on. That marks the end of this question. That was a pretty good question, mashallah. Okay. Let's go. Let's move on now. So let me see if we have any other question. So we don't. Let's move on to the next paper. So now we're gonna, I hope we find some other questions too, but alhamdulillah till now this is going good. सर चेक डिजिट डेटा के साथ अटैच होता है, बिल्कुल अटैच होता है. चेकसम डेटा के साथ अटैच नहीं होता, डेटा के साथ भेजा जाता है, इसमें फ़र्क है. ओके, सो एक चीज़ है कि मैं बोलूँ कि आई कैरी समथिंग अलॉन्ग साइड मी, सो मैं मतलब अपने साथ ये नोटबुक ले कर जा रहा हूँ. एक चीज़ है कि नोटबुक मेरे साथ अपेंड हो जाए, मे बी मैं ये बोलूँ कि मेरी स्किन के साथ इसको मैं स्टिच कर दूँ. नाउ दिस इज़ अपेंडेड टू मी. बट अगर मैं एक चीज़ हाथों में वैसे ही कैरी करके जा रहा हूँ तो वो अपेंड नहीं होती. सही है. सो कीप दिस पॉइंट इन योर माइंड. Alright, let's move on to the next question now. So let me look for a question regarding topic number 2, and then we can see what to do about it. So okay, that's a good question. Some diagram questions. So let's try doing this. सर ईयरली करा दे. ईयरली सिर्फ पास्ट पेपर सेशन के लिए जो रजिस्टर हुए थे उनके स्टूडेंट्स के लिए. सो या वी आर ऑलरेडी डन विद ऑल दीज ईयरलीज. So I'm just doing these topicals so that you can recap the concept. You're done with ELEs. So question number 7 says that a company has a network that includes a web server and that data is transmitted using serial half duplex transmission, and that you are basically required to create a diagram to show how data is transmitted using serial half duplex. So when we talk about serial, this basically means that a single wire is used to send data. Okay, single wire. Whereas when you talk about half duplex basically means that data could be sent in both the direction, but at the same time the data is only being sent in one direction. So now you need to draw and annotate this diagram to explain how you need to do it. So it's pretty much straightforward because we are sending it from a computer. The first part is that you make a computer. Okay, so you make a box like this, and then we make another box to indicate that it's my web server. Oh, that's not neat though. Let's make it a bit neater. So yeah, so it's gonna be another box up here, that's my web server, and now I'm gonna annotate it. By annotating I mean that you need to fill it up with stuff too. Okay, so computer followed by your web server, and now data is going to be sent from the computer to the web server. So we have one wire, so I'm gonna say one, or like data would be sent over over a single wire, and then what you can do is that we can write, because the bits would be sent one by one, we all know that, right? When you make use of the serial method, we say that one bit will be sent over a time. So I can say data will be sent over a single wire, one bit at a time. Why one bit at a time? I basically means that it's going to be going in a way that, okay, 1 is going to be ahead, then 0, then 1, then 0, 0, 1, 0, 1, 0. So like the binary is going to go in a way that it's going to go one after another. It cannot be possible that 1, 0, 1, 1, all of them go at the same time, so that the receiver gets them at the same time. No, the receiver is first going to receive 1, then it's going to receive 0, then it's going to receive 1, and so on. This is what we mean by saying one bit at a time. But right now it is only transmitting in one direction. Because it's half duplex, it should also go backwards. But then you might have a question, sir, how do I create the other direction. If I make something like this, that will demonstrate that it's full duplex. This would show that it's full duplex because it's being sent in both the directions. So whenever you want to demonstrate that you have something like a half duplex one, where you say that data is sent in both the direction but in one side once, what you do is you make a line but with dashes in between, so something like this. Okay, so you make it like this, and this indicates that okay, data is sent in both the direction but in one direction at a time. So you can now write data is sent in both directions, but not at the same time. And writing this will get you 4/4. Remember one important point: for you to get the marks for these annotation, these points you write, you need to show that on a diagram. So if you did not show something on a diagram and you are writing its description, you will not get marks. Point number 1. Point number 2 is, if you don't know anything about the concept and a diagram question pops up, just make the diagram by mixing some shapes, and you try to explain the concept by joining stuff the way you understood it, and then you write its English statement next to it. Examiner will award you somewhat marks for it. Clear? Alright, let's move on. Okay, so part B now says that give 2 benefits for the company for making use of serial half duplex transmission for this purpose. So firstly, this question says that serial half duplex. So the best answer would be if you write 1 benefit for making serial and then 1 benefit for making half duplex. So definitely, if I might want to give a benefit for serial, it's going to be that the bits will not be skewed. Okay, so bits will not be skewed. So I can say bits will not be skewed. Secondly, the second benefit you can talk about that whenever we make use of serial transmission has less interference, right? Because it has less interference, we're going to say that the chances of errors are also low. So I can say less interference, and hence low chances of errors, and hence lower errors. Okay, so writing this will basically get you a perfect 2/2 in this question. You can also talk about other points, that the data could be sent over a longer distance. You can also say that data could be both. It could be both uploaded and downloaded, because you can upload the data at one time, you can also download the data at the same time, but it's like you cannot do the 2 things together, but yes, you can do both of the 2 things separately. Okay, so yeah, transmission speed would be adequate. Talking about transmission speed up here might not be a relevant point, because transmission speed does not depend upon that. Transmission speed depends upon the transmission method. So if it was parallel, then I could have said that there will be higher transmission rate, but because it's serial does not guarantee high transmission rates, and because the question asks you for the benefits, you cannot write any negative points about the serial transmission rate. So the transmission rate would be low. Sir, serial में are bits not skewed or data not skewed? The bits are not skewed. आपने bits को बोलना है. Basically, not skewed का मतलब है कि अगर data is being sent like 0 1 1 0, तो skewed का मतलब है that it becomes out of order. So rather than at the receiver end ये कुछ ऐसे बन जाए. So this means that it has lost its order. Sequence इसका ख़राब हो गया. This means that it got skewed. So when it gets skewed, तो I don't say that the data becomes skewed. I just say that the bits, zeros and ones जो थे वो आगे पीछे हो गए. Serial is good for larger distance. Yep. So sir, half duplex is faster. No, not half duplex. You say that full transmission, whenever we make use of parallel transmission, that's faster. Parallel transmission is faster. Serial one is slower. Okay, serial one is slower. And speed does not depend whether you talk about half duplex, full duplex or simplex. Okay. Alright, let's move on. Part C now says that give 1 reason or drawback perhaps for making use of this. And now you can talk about the same drawback which we were just discussing, that the transmission of the data may be relatively slow. Okay, so we can say that the transmission of the data would be relatively slow. And you can also talk about the point that the second drawback is that data cannot be both sent and received at the same time, because it's half duplex. cannot be sent and received at the same time. At the same time. Sir, duplex and full duplex same? No, it's either full duplex or it's half duplex. There is nothing like duplex. So we're gonna start off with chapter number 3, inshallah, at 5 p.m. Okay. So we're gonna do some more questions. We're gonna first take a small break of 5 minutes and then uske baad. Let's move on. So let's see if we can find some other questions. So okay. But this is from chapter number 5, so let's leave this. This is chapter 3. Chapter number 3, again chapter number 3. So you guys, if you guys were asking for this paper, guest paper, right? So I have a guest paper for you. Please ensure that your chapter number 3 is super strong, because a lot of questions are going to come from topic number 3, so you don't want to miss upon them. Okay, this is a tip from my end. So the transmission rate would be low. ये point exam में लिखो तो full marks मिलेंगे. Transmission rate would be low नहीं, आप इस तरह लिखो the transmission would be slower. Okay. या मे बी ट्रांसमिशन रेट वाली पॉइंट भी हो सकती है, बट इट्स बेटर कि आप ये लिख दो दैट द ट्रांसमिशन रेट वुड बी स्लोअर रिलेटिवली. ओके, majority of the paper, no, it's not majority of the paper, but still, you know, a lot of the questions do come from chapter 3. Sir, please do this question. Okay, let's try to do this question. So summer 24, paper number 11, QP 11, question number 9. Let's try to solve this question on the request of one of our students. I hope it's not a very challenging question कि मैं भी खुद ही cook हो जाऊँ, but yeah, okay, oh, bro, it's not that difficult question though, but yeah, let's do it. So the question says, that's a pretty good question and it's pretty long though, so let's just paste it up and let's do it. So it says that a company owner has installed a new network and that data is correct before it is transmitted across the network, but the company owner is concerned that the data might have errors after transmission. Explain how the data might have errors after transmission. So how could this happen that some sort of error occurred? So it could be from multiple reasons. I can say that maybe the interference occurred, due to which data or data collision could occur, due to which data could be lost, data could be gained, data could be changed, or like bits could reassemble itself in the wrong order. So you can talk about all these points. So I can say interference could occur, interference and collision could occur, and collision could occur where bits could be added, removed, could be added, removed, or their order might be changed, or their sequence order might be changed. Sequence order might be changed, or you, that's also perfectly fine that if you write that some packets may have been timeout, that's also perfectly fine, but you need to write data packets. Okay, so or their sequence order might have been changed, hence an error has occurred, Okay, moving on. There's a student stated that packet sniffing is wrong. Why? Because packet sniffing does not mean that an error has occurred. Packet sniffing is the concept where, if let's say data is sent from person A to person B, if a hackers try to get access to a packet up here and they try to get access to this packet, they do not put something inside it, they just grab it out of here and they get access to it. That's known as packet sniffing. Okay, so packet sniffing is wrong. That's wrong. So can we do questions from chapter 4? The sensor type on realistic वही कर लेंगे ना, क्यों परेशान होते हो? कल chapter 4 करेंगे. Please guys, कल chapter 4 होगा. So Fortnite में packet loss का क्या किया जाए? Good question. Sir, can we write malware in the transmission network? Malware in the transmission network? No. या बल्कि नहीं बल्कि yes, you can, why not? So you can talk about how the network could be infected with malware, because वो infect होगा, that because of that new stuff will be added or the data would be changed, and because of that you can say that an error might be occurred. सही है? So that's the thing. This is such a big document, it has like all my physics university question solution, so I don't know, मैं ये share करूँगा तो आप इसमें ये ढूंढोगे कैसे. It's going to be very challenging, but I'm going to try. Okay, I will try. Part B says that the computer owner decides to introduce an error detection method to check the data for errors after transmission, and that the error detection system uses an odd parity check and a positive automatic repeat query. Describe how the error detection method operates to check for errors. 8 mark question. 8 mark question. 8 mark questions basically means that you need to write 8 points. 8 points. That's a very big question, and you need to explain the whole stuff. So first and foremost, explain the parity method, where they said that they are going to be making use of odd parity check. So I'm going to say that when you want to make use of odd parity check, you're going to count the number of ones, and that each byte has a parity bit. If the number of ones are odd, the parity bit is 0, otherwise it is 1. Okay, so you're going to first and foremost talk about, yes, you need to explain both of them. So I'm going to say the number of ones are counted. The number of ones are counted, and then each byte has a parity bit, which, if the number of ones, so this question is basically asking, what if we might want to use of parity plus ARQ together. So it's sort of merging two solutions together. Okay, so it's sort of joining both of them. So you can say, and then each byte has a parity bit, which, if the number of ones are are even, are even, then the parity bit value would be what? Then the parity bit would be 1 to make the number of ones odd. Otherwise, because the number of ones would be odd already, so I'm going to set the parity bit value to be 0. Otherwise, the parity bit value is 0. Parity bit value is 0. And now, once this has been done, now I'm going to send this data. So I'm going to say that the data is going to be sent, and the way our ARQ model works is that in ARQ you basically make use of the logic, as in that when the data is sent, a timer is started. Okay, so now the receiver receives the data, they count the number of 1. If they see that, okay, the parity has been matched and the data is perfectly fine, they send a positive acknowledgement. If the positive acknowledgement is sent, this means the data has been perfectly transmitted. If the positive acknowledgement is not sent within the specific time, then it's going to be assumed that the data has been transmitted incorrectly, so the data would be resent. That's the method of ARQ. So I'm going to now talk about the second point. So I'm going to say the data is sent, the data is sent, and a timer is then started, so this is like the ARQ method now. Okay, so now once it reaches the receiver is now going to check whether it's correct or not, using what? Using the parity method. So now I'm going to say the receiver is going to check the parity again, by counting the number of ones, if there are odd number of ones, this would mean that the data has been correctly transmitted, and then you're going to talk about, and hence a positive acknowledgement would be sent, and let's say if the timer runs out, because it also says that we have a timer, right? So I'm going to say that if the timer runs out, a negative acknowledgement is sent, and hence the data is resent. Acknowledgement is sent, and hence the data is resent. One important point here to note is that sometimes you want to write some word the way I extended it up here. I did this wrong. Okay, don't do this in exam. In exam, you have such bars at the corner of the exam paper, and those bars specify that okay, this is the region which should be scanned. So anything which is coming out of that region, that will not be marked. Okay, so if you want to continue, just add a dash up here and write it up here. Don't take it outside the lines. So if 2 bits were flipped here, the error would not be detected. Yes, you are correct, the error won't be detected, but the question did not ask us for that. It just says that okay, they use this, so how will this detect? So we're just going to write about the positive points. So just know this basically means that a question can also come up on ARQ plus checksum. Okay, so you should understand how ARQ basically makes use of ARQ plus checksum. So now you can read this question once again, and it will explain everything to you, and you would be good to go. So if timer runs out of a timeout and data is until body, yep, exactly, Zafar, perfect. Sir, कौन सी uni में है आप? I'm in LUMS. Alright, let me just grab the next question. So the next part of the question says that so are we just talking about one error section methods or all types? We're just talking about the question which has been stated up here. So this question clearly asks you to just discuss the ARQ method. So we are only doing ARQ method. Then the next part says that give two other error detection methods that could be used. So definitely we have a lot of error detection method. You can write any of them and you'll be good to go. So you can talk about what? You can talk about checksum. We can talk about the parity to ho gaya. Okay, parity ho gaya, so you cannot talk about parity. So you can talk about checksum, and you can talk about something like ARQ bhi ho gaya, echo check. So we can write checksum and we can write ARQ. Again, check digit will be wrong up here. Why? Because the question is dealing with transmission of data. So whenever you use the word transmission, check digit is basically wrong there. So remember this. Transmission equals to no check digit. Unless you are at a point where you literally forgot everything else, then you should write check digit. But yeah, say echo check is also fine. You can also write echo check up here. Alright, so echo check would also be fine. Sir, negative का लिख सकते हैं sir. So मैंने लिखा है ना negative का, ये देखो, a negative acknowledgement. So you can talk about negative. देखो लिखा है मैंने. We can talk about parity block. That's a good question about parity block, but what I would recommend is that because the question clearly mentions that आप उनके बगैर use करो, so it's better to go with checksum, echo check, or you can also talk about what we call it like parity check, but rather than it being odd parity check, you talk about even parity check. That's also perfectly fine up here. सर कोई echo check वाला करवा दे please. कोई question ढूंढो echo check वाला करा दे तो. Alright, let's do this one other question and then we can have a small break, and we're gonna start off with chapter number 3 afterwards, inshallah. So let me just find a question. Oh, by the way, why is this question pretty simple? Okay. So don't we have the Feb March paper? Let me just do this Feb March paper. Also, I'm gonna upload the scripts today, so don't worry. Okay. I'm gonna make a reel on my Instagram today. I'm gonna share 2 scripts. One is of a student who scored 71 out of 75 in paper 1, and then the second one scored a 71 out of 75 in his paper number 2 too. Say, so yeah, let's move on. So let me find this last question and then we can move on to with a small break and then start off again. So let me see. We don't have a question for chapter number 2 up here. That's crazy. Okay, we don't have a question. Okay, yes, congratulations, we got echo check, guys. We got echo check. You guys got, and also the parity block methods. Okay, you're happy. Get happy. We got good questions. So let's try doing this. So the question says that at the end of each day, the self-driving. Sir, do you think you got full in paper number 1? Back when I was appearing, paper number 1 got cancelled due to 9th May. So my paper number, I didn't give my paper number 1. That was like, it got cancelled. Which I don't know, maybe was a good part because no one knew programming, and I had done programming courses from UPenn, University of Pennsylvania and University of Michigan. And so I was pretty much good with programming, and so I aced that programming 15 marker, alhamdulillah, and it was really good. Yes, this is the tractor one. So let's try doing this question. It says that At the end of each day, the self-driving tractor transmits the data it has collected to the farmer's computer in their house, and that the transmission uses an echo check. Describe the role of the self-driving tractor and the farmer's computer. So you need to explain it in regards to how the data is sent from the computer to the tractor. So you need to write and talk about both the tractor and the computer in this regards. So how generally EchoCheck works is that data is received, the data is sent back to the sender. He then compares it. If it's the same, then they send a positive acknowledgement. If it's not, they send the data back. That's the logic. So now if you have to describe this whole thing, the way you're going to say is that the same data which has been transmitted, it's basically sent back from the computer to the tractor, and then the tractor compares the two sets. If they're identical, then this basically means that it's perfectly fine. If not, they resend the data. So I'm going to say that the data is transmitted back from the computer to the tractor, How do I know this? Because it says that the tractor transfers the data. So the data goes from tractor to computer. So the computer sends it back to the tractor, and then the tractor compares the data. Then the tractor compares the two sets of data, and if they are not equal, or if they are not same, the data is resent. The data is sent again. And writing this will basically get you a 3x3. That's the whole process of explaining echo check. Went to UPenn for courses and ended up I hope when you guys apply to universities you understand that it's not that crazy. I got rejected from UPenn though, but the courses which I did, they were online. I did not go physically, okay? But yeah, I did have like 3 full rides in Hong Kong. I had like a full tuition in the US. I had like some partial scholarships in Turkey and Germany. So I had a pretty good profile. I ended up selecting Hong Kong, but then my conditional offer got missed by a few marks because they needed an A star. I ended up getting an A. So because of that reason, I'm at lumps. So yeah, lumps is really good too. So yeah, so the tractor would send the data to the farmer computer would send the data back. The tractor would then check the data with the original. If they aren't the same, then there is an error. So you don't say just error, then you also talk about the fact that the data is sent back. Okay? And also these courses which I did, that was something I did out of my own interest. What is the best grade? If you start off, yeah, that depends upon you, how good you learn it. If you want to lock in the crazy way, you can easily grab an A or an A star. Even at this point, you are very much close to getting an A. If you take that paper number 2 score to like 45, you can get an A easily, inshallah. So yeah, and if you give it your best and you somehow get this 35 to 60, which is possible, to phir ho sakta hai. You can even end up getting an A star. Alright, let's move on. So that's how you answer this parity method question. And now the next question is in regards to this parity block, where it says that this is a good question, you should be aware of it, okay? It says that another method of error checking is a parity block check, okay? And that the table shows 7 bytes that are transmitted using odd parity, and that the parity bit has been completed for each byte, okay? So you need to complete the parity bytes. So the way this happens is that you basically count the number of ones and zeros, okay? So because it makes use of odd parity, this means that the number of ones were basically should be odd. So let's count them. So 1, 2, 3, 4. So it's even, so we need to make it odd. So we're going to write a 1 up here so that the number of ones are odd. Similarly, 1, 2, 3, 4, 5. So this is already odd, so I'm going to put a 0 up here. Then 1, this is odd, so 0. Then 1, again odd, 0. Then 1, 2, 3, 4, so I'm going to put a 1 to make it odd. Then 1, 2, 3, 4, 5, again 5, odd, so I put a 0. Then you have 1, 2, 3, 4, so 4, so you could put a 1 up here, okay? And the last one is 0, 0, 0, 1, 2, 3, so 3, again you put a 0. That's it for the parity byte method. Now if it asked you, like they gave you something like this and it says that detect an error, how will you find an error? Let's say there was an error at this point, it was a 0. So what you're going to do is you're going to count the number of ones both horizontally and vertically. So you're going to see where, in which of this has the parity not being met. So this is met, this is met, this is met, this is met, this is also fine, this is fine. But if I find it for this 1 and 2, this is even. So I know that one error is up here because this should have been odd. So one error comes up in this row, okay? And then I'm going to look at the vertically, I'm going to count them one by one to see whether they are odd or even. So this is odd, this is odd, this is odd, this is also odd, and now count this 1, 2, 3, 4. So this is even, so this is wrong and the others are correct. So because this is wrong, this also tells me that an error is in this column. So if the error is in this column, wherever the column and the row matches, we found out that the error is basically at that position. So this shouldn't have been 0, this should have been 1. That is how you use the parity block method to basically get the answer. सर आपकी 2 प्लेलिस्ट इनफ फॉर पेपर 2 कोडिंग पोर्शन. यस, कोडिंग पोर्शन के कॉन्सेप्ट्स आपके क्लियर हो जाएंगे अगर आप वो अच्छे से देख लो, सही है. एंड उसके बाद सारे मैराथॉन्स देखो विच वी हैव कंडक्टेड, एंड इवन उसके बाद आप बाकी चीज़ें भी कर लो तो गुड हो जाएगा. Anonymous guy, love you too. Well, I can't totally understand most probably who this goated person is, but thank you so much, man. So ये पैरिटी बिट तो आसान है, कुछ और करवा दे भाई. अब कोर्स ही आसान है तो उसका मैं क्या करूँ यार. CS तो है ही बच्चों वाला. CS में मुश्किल जिनको लगती है, मैं कहता हूँ यार आप लोग अजीब लोग हो यार. CS में क्या मुश्किल है. दिस इज़ द एग्जैक्ट स्टाइल ऑफ क्वेश्चन यू आर गोना गेट. जो आप लोग देख रहे हो, अभी तक हमने एक सवाल भी मुश्किल नहीं किया. बट या वी हैव कवर्ड अप द इंटायर पेपर नंबर 2, पेपर नंबर 1, चैप्टर नंबर 2 इन ग्रेट डिटेल. जितना हो सकता था. वी डिड अ लॉट ऑफ क्वेश्चन. सो वी डिड लाइक 1 2 3 आई डोंट नो, अच्छे खासे 6-7 सवाल किए होंगे. एंड इंशाल्लाह I hope this was good enough. So now let's take a break for like 7 minutes. We're gonna come back at 5:15 inshallah. Okay, so that's great dedication Uzafa. Inshallah if you give it your best, aapka ho jayega inshallah. Okay, so you have a break till 5:15 inshallah, and then after that we're gonna jump on to some chapter number 3 questions. We're gonna specifically do chapter number 3.1 plus chapter number 3.2. I'm gonna focus on this a lot because this is something which examiner has been tested a lot. Okay, alright, let's then just move on and see you guys afterwards. So we also have, guys, a shout out to Chem Fusion. We have Sir Ahmed Shahab with us here in the live stream. Sir Ahmed Shahab is one of the most Pakistan's talented chemistry teacher. Okay, so Sir Ahmed alongside Sir Suleiman, these two are like the most goated chemistry teachers you can find. Okay, so if anybody has any problems with chemistry, go search for Carboxyl Chem and search for Chem Fusion on Instagram, and you're gonna get a lot of crazy resources out there. Okay, so it would be good to go inshallah. Sir, how do we answer like bit 4? So if a question like this comes up, so in exam they're gonna just give you that in what bit and what byte did the error occur. So you need to exactly just tell that it's bit number 4 and it's byte number 4. And if it was an answer, you just write that the error occurred in bit 4 and in byte number parity 1, something like that. Okay. Sir, aap aur Sir Ahmed ka Sir Ahmed and me are very good friends. Both of us are in LUMS, and Sir Ahmed goat, Bakri, sahi hai. Shout out to him. How long will this be? So it's going to be 1 more hour too. Why didn't I move to the US? Because that university was not that good. So I did not find it appealing to move to that state. Can you do one question with parity block in which how can we get to know which one is right, like the one parity block one? So we just did this question. That's how you're going to find it. If you guys can find a question in the break where I can solve it, but if you cannot, फिर मैं कहाँ से ढूंढूंगा. So try to find a question if you can and then let me know. Okay. Alright, that's it for today. That's it for right now. We're going to have a 7 minutes break. So I'm going to give you break till 5:17, okay? Perhaps let me check the Asr Namaz time so that you guys can also pray Asr in between rather than, let me check. So Asr is at, okay, it's also Asr time. So we have a break till 5:22 then, okay? Pray Asr in between too. You can go drink water and pray Asr. And then after that you can come in. इंशाल्लाह मैराथॉन्स करेंगे. सर हैव यू बिन टू पाकिस्तान? क्या सवाल है मेरी जान, क्या सवाल पूछा आपने. लेवल कर दिया रिजलर भाई, लेवल. Alright, let's just go on a break. See you guys inshallah at 5:22. Oh yeah, so the microphone was turned off. Thank you very much. Yeah, you guys would be able to hear me right now. I'm audible, right? Everyone in the chat box, Shabash, quickly tell me. Yeah, yeah, it's now opened up. Alright, let's just wait for 2 more minutes for the rest of you to join in and फिर start करते हैं. Will we cover all the chapters? Yes, inshallah, before your exam. So an expected A star could be around 115 to around 120. Depends upon the difficulty, but yeah, it could be somewhat around that range. Okay. So right now we're gonna start off with chapter number 3 questions. Okay, 3.1 specifically. All right, let's start off with this. By the way, it's 5:33, so let's start off. This is a really yeah, I wasn't speaking though. So this is a really important topic. I want you all to be very focused with this. Okay, so why was the threshold at 120 and 20, even though the 15 mark was considered to be the hardest? Good question, but it's because everybody, even though it felt challenging, students were still able to score marks. So if a difficult question comes up, but you are still able to score marks, the threshold is going to be high. Okay, so what topics are the most important? Every topic is important, but necessarily chapter number 1 is important. Like a lot of questions come from there. Chapter number 3 is really important. Apart from that, you have the other topics also really important, but yeah, like every topic does get tested. Okay, so don't worry. So let's start off. Shayan, we're gonna do it at the end if we have time. Okay, on a group में पूछ लेना. Alright, let's start off with chapter number 3. So let me open up the paper. We're going to start off with summer's paper for 2024, and we're going to first and foremost do the questions for chapter number 3.1 specifically. Okay, so in 3.1 we basically have scenarios regarding the computer architecture. So you get everything regarding how your computer works, the fetch, decode, execute cycle, and all that stuff. So we're going to basically discuss that first, and then we're going to move on. Okay, so we have this one question which is a part of another question, but we're going to solve it, which is a really good one because it asks you, explain why a computer needs RAM. This is one of the most commonly tested question, where they either ask you why does a computer need primary memory, or why does it needs RAM or ROM specifically, right? Questions like this. So remember that you need RAM to store data temporarily which is currently in use, so that it could be accessed faster, because it's way more faster than the secondary storage, and this basically allows us to do the fetch execute cycle, right? So it's a 3-marker question, and it expects 3 points from you. Firstly, to store data temporarily. The word temporarily is really important. Okay, to store data temporarily that is currently in use, because RAM has a faster access time, in comparison to your normal secondary storage. You can also write one other point that it's not only going to store the data which is currently in use. You can also write that it's also stores all the softwares which are currently opened up. Okay, so that's also a valid point if anybody wants to talk about that. Comparison to secondary storage. So you had to write these 3 points, and upon writing these 3 points, you're going to get a perfect mark. Okay, so or you can also write this one extra point that it speeds up the fetch stage of the fetch decode execute cycle. That's also a perfectly valid point. Okay, I did not open up the chat box. Just give me a second. Chat box. So yeah, open up the chat box. Yeah, perfect. So let's move on. So the next question now says that you need to draw the annotate the diagram for the fetch state. So when we talk about the fetch state, this means we are talking about the program counter. When we are talking about the MAR, then we are talking about the data going into MDR. Then we are talking about how the data is basically going to go into CIR. Sajid, I did answer that question. We cannot say anything about the threshold at this point without seeing the paper. Okay, if it was an easy paper, the threshold can go up to 125. It was a very difficult paper. It could go up to like even 105. But if we consider it to be a normal average paper, the threshold could be around 115 to 120. Sir, what chapter is your question? Is this question from? So it's from chapter number 3.1, computer architecture. So now when they ask you to make a diagram, you need to only talk about the fetch part. So in fetch part, you have the PC, MAR, MDR, RAM, control unit, and CIR. Okay, so the way it works is that I'm going to make it in a way that I always going to have first and foremost a program counter. Then from the program counter, the data is going to go into something we know as MAR. Oh my bad, I don't want to copy the whole thing. I just want to copy this part. Oh, it does not get copied that way. Okay, no problem. So we have program counter. The program counter sends data into MAR. The MAR basically sends the data into MDR. And then from the MDR, the data goes into what? It goes into my CIR. Okay, so it goes into CIR, and we all know that CIR is basically what? It's something within the control unit. So we say that the data goes from MDR to CIR, and now if I want, I can make a diagram. Maybe this is an option step though, but if you make it, you're gonna get 1 mark for it, that this CIR basically operates under the control unit. And this all together, when you join it up, it's basically going to discuss the fetch part, and then anything that's coming from here, that goes into my RAM. So from the MAR, it's going to go into RAM, from where I'm going to get permission to basically access the data. So it goes into RAM, and then the RAM is then interconnected again, because what if I want to send the data? So that goes back into my MDR. So we have to make this. And now no sir, doesn't it go into the RAM? It's yep, I did show this. Chill. And now you need to explain the whole thing. Okay, so you explain the whole stuff in a way where you first and foremost tell that the instruction is sent to the CIR to be decoded, or like starting from here, you can talk the PC increments, and the address is sent to the MAR, and the address is sent to the MAR. Try to keep some space, by the way. Okay, point number 1. Then the second point you can talk about is the CIR one, where you can say that the instruction is sent to the CIR for decoding. The instruction is sent to the CIR for decoding. So you need to write this description. Okay, this is really important. Is sent oh, why is my graphic tablet lagging at this point? So the instruction is sent to the CIR for decoding. Point number 2. And then you can also talk about the third point up here, which could be that the address is sent from the MAR to basically your RAM, or you can talk about the fact that basically the instruction is sent to the MDR using the data bus. So you can talk about that this is my address bus, so you can talk about that address bus, and that the data is sent using address bus, and you can talk that this is basically my data bus, where the data is being sent through data bus from the RAM to MDR. Okay, that is everything you need to know. That's how you're going to solve this question. Let's move on. I will try to find a question which explains this topic of what do we call it, stored program. So I'm karenge. Okay, alright, perfect. So that's the only question from chapter number 3.1 in this paper. Let's move on to the next paper now. So yeah, let's do this. So I hope we have a question up here for this topic. Paper number 12. So yeah, how long is the class going to be? So it's going to go till around about 6:20ish, inshallah. 620, 630 most probably, somewhere around that. Alright, so that's a really good question from computer architecture. It's a 7-marker question, and this is something which you guys need to be very clear upon. Messing up such questions will cook you. Huzaifa, can you check what paper was it where the stored concept was tested ताकि मैं वो explain कर सकूँ? Stored concept, what do we call it, program concept is just the same thing as saying that you have basically your fetch execute cycle. So you're storing the data. That's the whole logic. Okay, but yeah. Okay, Mustafa, can you please find the question and send it to me, or let me know the question and I can then solve it. Okay, so this question says that instructions are processed by the CPU in a computer. This is question number 2, and that you need to complete the paragraph about fetching. Again, remember, when it talks about fetching, you need to talk about program counter, then you need to talk about MAR, MDR, and CIR. That's the main logic when you talk about generally about fetching. When you talk about the decoding part, the decoding part generally involves stuff like control unit. Okay, control unit and its signals being sent. And then if you talk about the execution part, then that is something which hasn't been tested, but you can say that it might include ALU, accumulator, and all those registers, so that it could store the value and it could process it up, and then finally it can ask the CPU to refetch the data so that it could continue. Okay, so yeah. So should I do ELEs now? I would recommend doing topicals though at this stage rather than ELEs, but yeah. Let's move on. So question 5A says that complete the paragraph about fetching an instruction into the CPU for it to be processed. So you need to use the terms from the list. Some of the terms in the list will not be used. You should only use a term once. So it says that the program counter contains the dash of the next instruction. We know that the program counter always contains the address of the next instruction. This address is then basically sent to the MAR, which is the memory address register. Okay, so I'm going to write MAR, or like the full form, perhaps let's just save time, MAR. And how do I know that? Because one hint is that they made use of address bus. Address bus is something which is associated to your MAR, remember that. Okay, then moving on, it says that once this address the address is then sent to the dash. So we generally always assume that it's going to be something where the MAR directly jumps into your MDR, but it's not that way. It's basically that you have MAR, and then the MAR sends the request or the address first to RAM, and then the RAM basically, once that receives the address, the instruction is then stored at the location which is at that specific point. That address is then asked to basically grab the data. So then you need to basically grab the data using what? Using the MDR. So we say that once the address is received, the instruction is basically stored at the location in basically sent to the MDR using the dash bus. So again, memory data register. So this means that it should have data being carried inside it. So data could only be carried using a data bus, hence data answer for this. Should I do topics from 23 onwards? So you should only do questions from 2023 onwards. Okay, and then the instruction is then sent to the dash that is built into the dash. So let me see. So the instruction is then basically sent into the CIR, and then CIR is basically a part of what? We know CIR is basically a part of control unit. So I'm going to say that the instruction is then sent to the CIR, which is my current instruction register, and that is built into what? It's basically built into control unit. This basically means that control unit is like the bigger part, and within the control unit we have something known as CIR, where the instruction comes here from the MDR. That's the whole logic. So if you mess this up, you're going to lose 7 marks. So please be very clear with the usages of each of these components so that you don't lose marks at all. This is really easy, and I don't want any one of you to lose marks at all with this. Alright, let's move on. Alright, perfect, Mustafa. Let's do it after this. Okay, inshallah. So let me see, do I have any other? Okay, so we do have a part B. Part B says that the CPU uses an instruction set to decode the instruction. What is an instruction set? Instruction set is basically a list of all the commands or all the operations your computer can execute. So it's basically a list of all the commands that can be processed by the CPU. Instruction set is a list of all the commands. Is a list of all the commands a computer can process. Of all the commands a computer can process. Computer can process. Just know one thing, that when we talk about instruction, instruction is basically divided into two things. We have the op code and we have the operand. We studied this even that day, remember? You have the op code and we have the operand, where one basically represents the data and the other represents the operation upon it. Now when we combine all these instructions, when which my computer can execute, like my computer can do a limited task, right? Like I cannot ask my computer to take me to space, right? It does not have that instruction within it. So the instruction which it knows, if I combine all the instruction which it could process, the list which is being formed, that is known as basically the instruction set. This question is also something which is not frequently tested, so you should be well aware with this. Alright, let's move on. So, do we have any other questions from chapter number 3.1 up here? We don't. Alright, let's move on to the next paper now. So, let's do paper number 13 now. So, paper number 13 has a question about, let me see, do we have a question? Okay, RAM, ROM, ये बात की कहानी है. इनपुट आउटपुट बात की कहानी है. Perhaps साथ ही कर लेते, क्या बात की कहानी करेंगे. That we were gonna just waste the time. Okay, so let's do chapter number 3.2 का question up here, which is from input output. So it says a sensor is an input device that is used to capture data from its surrounding environments. Circle 3 other input devices. One important point here to note is, please see whether it's circle or underline. Sometimes they write underline, but because we have always seen it circle, we encircle it. That's wrong. You need to underline it. So please keep this in your mind. You need to circle 3 other input devices. Touch screen an input device? Yes, it is. Is hard disk an input device? No. Is headphones an input device? No. Because headphones is basically sort of speaker. It's an output device. Is speaker? No. Microphone? Yes. Actuator? No. Output device. USB? Let's see. Is printer? Nah. Keyboard? Yes. So USB is also wrong. Why USB drive? It's saying drive. Drive is something which comes under the storage part. It's talking about the USB pen drives which we have. Hence the answer this will also be wrong. Part B now asks that the sensors can be used in an automated system. Give 2 benefits. So what are the benefits you get if you make use of sensors? What are the benefits? We have a lot of benefits when we make use of sensors. A few of them could be in regards to how, like, what do we call it? When you make use of sensors, data could be collected faster without any human intervention. It will be even more accurate. The data could be taken like 24/7. It can take reading in dangerous environments. All of them are perfectly fine. Okay, so I can say that data can be collected. Data can be collected without any human intervention. Without any human intervention, which is point number 1. And point number 2 would be that basically it can gather the data faster than users. So gathers the data faster than users. So like if I have to manually measure the temperature, that's going to take me a lot of time, and there is no accuracy or reliability that I might be 100% correct. But if it's a sensor, it's going to be pinpoint perfect. Okay, so therefore this is going to be the answer to this question. Moving on, let's see if we have a very good question, which basically is the only question which might be a bit difficult from the sensors topic, where they ask you to basically tell us where could each of the sensor be used. Now if you open up our notes, which are available on chapter number on our website, for all of the sensors we have listed where they could be used. Okay, so just memorize at least one user, because now this question says that the table contains different types of sensors and a use for each. Complete the table by giving a suitable use for each type of the sensor. The first one has been done, acoustic, so it's the sound one, so it's used to monitor whether a water pipe might have been cracked and is leaking and dripping onto the floor. Then the second one is temperature. Where could temperature be used? So I might be able to make use of a temperature in a room that has climate control, like those automated ACs. So like when the temperature is above 25, turn on the AC, something like that. So I can say to monitor the temperature in a room that is climate controlled. Monitor, or like even in the greenhouse, that's also fine. So I can say monitor the temperature in a climate control for a room or greenhouse, /greenhouse. So you can write any other points which is applicable up here too. Okay, moving on, the second one is humidity. So where could you make use of an humidity sensor? You can check it to maybe check it in. Okay, now let's say we can write the greenhouse point here again. So it's better to write the room one up there, and we can write the greenhouse one below. Why? So try to see, don't repeat the point. So you can say to check whether the air is moist enough in a greenhouse. So check whether the air is moist enough for a greenhouse. Moving on, third one says infrared. Where can infrared sensors be used? So you have a lot of places where infrared could be used. It could be used to detect motion in a room for, like, let's say security system. That's the best one. Or you can say whether a person is like approaching automatic doors, like those doors in front of those malls. When you go in front of it, it automatically opens the door. It's basically infrared sensor which automatically opens them for you. Okay, so you can write about that too. So I can say detects motion in a room for security system. Detects motion for a room in security system. Then we have the magnetic field. What's a magnetic field? It basically could find well, let's say, so magnetic field can count stuff. Okay, so I can say that it basically tells us how many vehicles have, let's say, passed a specific point. So I can say counting the number of vehicles that cross a bridge, or I can say monitoring the vehicles that enters a car park. So it can allow us to count stuff. Okay, so I can say counting vehicles that cross a bridge, counting vehicles that cross a bridge, or like counting cars which have basically entered a car park. Okay, that's also perfectly fine. And that is how you need to answer this sensor question. Moving on, let's try to find some other question. Let's see. Yep, we do have a question in the same topic paper. So it's from CPU. That's a really good question. So you see that sensors are being again and again used. So like there are even more than one questions from chapter number 3. That shows the importance of chapter number 3. You cannot miss upon chapter number 3. It's so important. Please do a lot of topicals for it. So question number 8 says describe the role of a CPU. So what does the CPU do? A CPU basically acts as the processing unit for us. So we say that it basically processes the instructions. And when we say that it processes the instruction, this means that it runs the fetch, decode, execute cycle. So I'm going to say it processes instructions and executes the fetch, decode, execute cycle. And doing this will get you 2 by 2. Okay, moving on, part B says that the CPU contains a register. So state the purpose of a register. So what's the purpose of a register? So it basically is a component or a hardware piece which basically allows you to store data temporarily. So I can say to store data temporarily. And this will get you a perfect 1 by 1 up here. Then it says give 3 registers that are built into the CPU. So we have a lot of registers. Again, you're just required to talk about registers. So the special purpose registers, the best are you talk about MAR, MDR and program counter. Okay, so MAR, MDR and program counter. But if you write something like let's say control unit or ALU, then you're going to lose marks because those are not your processing units. Just give me a minute. Sorry, they are not your registers. So is the stream even working? Let me see. Why is it disconnected for me? Oh wow. So my phone apparently was disconnected this whole time and I could not see anybody of yours message and I was even shocked. भाई इस कोई सवाल ही नहीं भेज रहा. Wow, crazy. So sorry I missed all of the questions. Sahi hai? So that's the reason. Yeah, it's working. Okay. So are there any topic 5 notes from which I can study? You can. Everything is on my website. You can do all of them. Okay, and you'd be good to go, inshallah. So now we are good to go. So yeah, perfect. We're gonna do everything. We're gonna do chapter 5. We're gonna do chapter number 6. Everything, but those will be then done later on. So part C now says that one component in the CPU is the ALU. Okay, describe the purpose of the ALU. So your ALU has the purpose to basically execute instructions. It performs calculation, it performs logical operations, and it then stores the interim results. It writes it before, like it stores the data from the accumulator and all that stuff. So I can say that it asks you about ALU. So we're going to talk about the fact that it does what? It executes instructions. It executes instructions. Point number 1. Then you talk about that it basically perform calculations. It executes instructions and performs calculations. It also carries out logical operation. It also carries out logical operations, and stores any interim result. By interim I mean any temporary result. Okay, and stores any interim result in the accumulator. And writing this will get you a perfect 3 by 3. So in part A, can you write that it fetches, decode and executes the information provided? So if you write that in part A, you're going to just get 1 mark. Okay, and if you perform then you can store. Perfect. Okay, so it performs logical operation, stores result of it. It also performs arithmetic calculation. Other than saying that it performs, okay, yeah, that's also perfectly fine. So what's the website name? It's Code Catalyst. The link would be even in the description of the video. If you see the description, you have the website link within that, so you can also do it from, just open the website from there. Okay, if I don't write yep, you will still get full marks. Alright, let's move on. So let's see, do we have any other questions up here? Yes, we do. So this question says that the student wants to replace the CPU to basically improve the performance. Okay, so the student wants to replace the CPU to increase the performance of the computer. Explain why a different CPU can increase the performance. So now you need to talk about how a different CPU, which might have some more features, like it could have more cores, it could have a higher clock speed, it could have a greater cache size, can basically allow your performance to be improved. So it's a 4 mark point. You're going to take 1 point that it might have this, and then you need to explain how this improves the performance. So I could say that it could have more, the other CPU, the newer CPU could have more cores, could have more number of cores. And we studied this last night, that if we have more number of cores, this would basically mean what? This basically means that you could increase the number of fetch, decode, execute cycles that could be performed at the same time. So I can say the newer CPU could have more number of cores, increasing the number of fetch, decode, execute cycle. You need to write the full form. Fetch, decode, execute cycles performed per second. So performed per second. Okay, or performed at the same time, perhaps that's wrong. Perform at the same time, that would be the correct point. And then you can talk about the clock speed, where we can say that it's going to increase the number of fetch, decode, execute cycles performed every second. Then I can say the newer CPU can have a higher clock speed, and hence more fetch, execute cycles could be performed, but this time per second. Okay, and hence more fetch, execute cycles, more FDE cycles. Again, you need to write it in full form. Cycles can be performed per second. Okay, That's your second point. And writing this will get you a 4x4. But if anybody wants to write one extra point, you could also say that the newer CPU could have a greater cache size, which means more frequently used data can be accessed faster. That's also a perfectly valid point. So if you want to talk about the cache memory part, that's also a valid point which can improve the performance of your CPU. And writing this will get you a perfect what? It's going to get you a perfect 4x4. Clear, everyone? Alright, let's move on. So the next question is going to be now from some other topic. Let me find some topic. So we are done with the this paper 2, right? Yep, this is done. Okay, let's do the March 24 paper, and then we can take some questions from you guys if you found those to be a bit difficult. Okay, so don't worry. Sir, will you do a syllabus speed run one day before exam? No, I will not. I don't have time because I have my own final on the 14th. You guys should be thankful, man. I'm taking these 2.5 hour classes despite the fact that my finals are starting literally this week. But yeah, I hope you guys get to learn. That is what matters. Okay, so this is another good question. Let's see how we need to solve it. Kar lenge yaar, Shayan bhai, easy scene. Kar lenge. Chill. And I ask for questions, tab bhej dena, tab kar lenge inshallah. So this question says that a computer has a CPU and that the CPU includes the registers, program counter, MAR, MDR, accumulator, and CIR. And it says that the table contains 5 statements about the roles of registers in the fetch, decode, execute cycle. You need to tell them which of the 2 are not correct. Okay, so 2 of the values are not correct. So the first one says PC stores the address of the next instruction to be accessed. Acha, this seems to be correct. Second says MAR stores the instruction of the program that is running. No, that's wrong. MDR stores the data passed to it from the PC. Okay, question mark. Accumulator stores the result of each calculation. Yes, it does. CIR stores the instruction currently being executed. Yep, that's correct. So if I look up onto the statements, I've identified that one answer is supposedly clearly wrong, whereas for the other one I'm like, okay, it might be correct, it might be wrong, I'm not sure. So what's going to be the answer in this case? So whenever you get a question like this, remember, it's pretty much evident that I can see that B and C are the wrong because all 3 are perfectly fine. Is this a PDF or are you selecting from ELEs? I'm selecting them from ELEs, guys. It's not like a PDF. I'm just taking it from random papers. So this is going to be B. Why is B wrong? You need to write the correct one, because MAR, what it does is MAR stores the addresses, it does not store the instructions. So I'm going to say MAR stores the addresses of programs rather than the instructions. I even stated this that day. Feb March papers are not officially announced, hence they will not be solved by me. And then the second one is basically C, which says that MDR stores the data passed to it from the program counter. No, it is basically the data is from the address in MAR, not from the program counter. So I'm going to say data is from the address in MAR, not PC, in MAR, not program counter, PC. Okay, perfectly fine. Moving on, the same question then has another statement. It says that the CPU or the computer has a single core processor of 3.5 gigahertz and an 8 kilobyte cache. State what is meant by 3.5 gigahertz processor. This 3.5 gigahertz is basically my clock speed. Okay, for statement 2, why isn't it data stored passed to it from RAM? Like पहले MDR से RAM and then MAR पे नहीं जाता, वो point आपका valid है. That's a good point. But the statement says that it basically stores the data passed to it from the PC. So ये जो MDR store करता है ना, वो data उसके अंदर pass होते हैं from MAR के address से. So MAR का address जाते हैं RAM के अंदर, and I know RAM basically sends the address, but वो एड्रेस फिर भी MAR का ही होता है. सो लाइक स्टिल व्हेन यू गो एंड फेच द डेटा, जो आपको एड्रेस प्रोवाइड करता है, एड्रेस आपको MAR प्रोवाइड करता है, रैम नहीं करता है. रैम आप इस तरह समझ लो कि रैम आपका एक घर में बड़ा बनता है जिससे आपने इजाज़त लेनी है, शुड आई जस्ट गो एंड सेंड MDR मेरा छोटा भाई टू गेट द डेटा और नॉट. अब वो इजाज़त दे देते हैं तो वो रैम आपको बोलेगा कि ओके फेच द डेटा, बट MDR विल स्टिल गेट द एड्रेस टू ऑफ दैट लोकेशन फ्रॉम MAR, hence it has to be MAR. Would saying RAM be incorrect though? Well, to be honest, according to, if I look on to what do we call it, marking schemes always prefer saying that the address comes from the MAR. Okay, so it has to be MAR. Sir, will I get the marks though for C? What's your C point? B, C, B. Okay, but then yeah, you should ideally get marks for writing that it comes from RAM, but in the marking schemes which I have seen, they only ask you to say that the address is going to come from the MAR and not the RAM. So it's the marking scheme saying that it's going to come from MAR, so you're going to write that too. Sir, my preparation is zero. What action is this? Action ये है कि सो जाओ मेरे भाई. Best solution. सो जाओ, नींद पूरी करो. बहुत स्कोप है लिटरली. नेटफ्लिक्स भी देख लेना साथ. जोक से साइड कंटेंट को जितना कवर कर सकते हो एट दिस पॉइंट वो कवर अप कर लो, सही है. एंड साथ अगर आप पेपर नंबर 2 के लिए आपके पास 4-5 दिन होंगे तो उसके अंदर वो कर लेना, तो ये कर लेना सही. So sir, but sir, data comes from RAM, address comes from MAR. This isn't data. Yeah, so but it says MAR stores the data. It stores the data which is passed to it from what? Which basically means कि यार आपके पास data तो आ रहा है, वो तो MDR के अंदर store है. Data is MDR. But वो इसके अंदर ये address कहाँ से आ रहा है कि यार आपने इधर जाना है, वो address तो इसको MAR provide करे ना. Address is stored within the MAR. Remember, address is equal to MAR. Your RAM does not store the address. MAR stores the address. So यहाँ पे what is passed to MDR? The address is passed to MDR. कि bro, go to this address and grab the data and put that data inside yourself. That's the whole logic. Okay. Moving on, it now says that there is a processor with 3.5 gigahertz processor, and that what's the 3.5 gigahertz processor? This is basically my clock speed. What does the clock speed show? It tells us how many fetch, decode, execute cycles could be run every second. So I can say that because it's gigahertz, giga basically means billion. So I can say it can run 3.5 billion fetch, decode, execute cycles per second. So it can execute 3.5 billion fetch, decode, execute cycles per second. Guys, इस तरह नहीं है, रुको आप लोग कंफ्यूज हो गए हो. सो ये होता है कि प्रोग्राम काउंटर गिव्स द एड्रेस टू MAR, सही है. MAR गोज टू द रैम टू सॉर्ट ऑफ, आप ये एज्यूम कर लो कि भाई मुझे परमिशन दे दो सो दैट आई कैन सेंड एंड एक्सेस द डेटा. When RAM is like, okay, I'm free and I'm willing to process this data, so it's gonna get the permission. Okay, it's gonna give the permission, and now you need to grab the data. The data is stored in secondary storage. Okay, it's stored in your secondary storage. It's stored somewhere in a hard disk. So now to get the data from the hard disk, we send MDR. But MDR does not know where to go. So MDR gets the address from MAR. So the MAR provides its address. Okay, and then using this address, MDR basically goes to the hard disk. It gets the data from here. The data is then stored inside the MDR, and then the MDR basically goes to your CIR. That's the logic. Clear? RAM कोई डेटा स्टोर नहीं करती. It's basically RAM आप ऐसे एज्यूम कर लो कि आपको परमिशन दे रही है. कि इससे ज़्यादा कंफ्यूजिंग ना हो, जस्ट counted as if कि आपको एग्जाम्पल मिल गई कि it's just gonna give you permission that okay, I'm willing to process it up. Okay, yeah. And then it says that it has 8 KB cache. Now what is this? This is basically the cache memory which I was talking about. That small memory which is very fast and can further improve your computer performance. Yes, we will be doing scenario based questions inshallah. So we should have a question for that after this, right? So let me paste that question first. So it says that the CPU is changed to a 3.5 gigahertz processor. So okay, let me paste the question first. So the CPU is changed to a dual-core 3.5 gigahertz processor. Explain how the number of cores affects the performance of a CPU. So when you increase the number of cores, what's happening? When you increase the number of cores, it improves the performance. Why? Because more fetch, decode, execute cycles could be performed per second. So I'm just going to say this improves the performance. This improves the performance. And why? Because it can execute more fetch, decode, execute cycles per second. Because more FDE cycles could be executed per second. FDE cycles could be executed per second. Could be executed per second. Scenario based questions would be done inshallah from the 14th. Okay. So moving on, part 3 now says that the amount of cache is increased to 64 KB. Now we just said that if I increase my cache memory, if I increase this, why? This is going to improve my performance. Why? Because this is very fast, and if I increase this means I can store more frequently accessed data up here, which means that I can easily even store more stuff which can allow me to access it even way more faster. So that is going to improve my performance. So I'm going to say more cache memory will improve the performance of the computer, will improve the performance of the computer, which is point number 1. And then you say that how does it improve the performance? Because more data could be, more cache means that more frequently used data could be stored. More cache means more frequently accessed data, more frequently used data could be stored. More frequently used, so wouldn't per second be for clock speed? So where did I write? Okay, yeah, say 1 second. Yeah, you are correct. Simultaneously, executed simultaneously. Thank you, Mustafa. Simultaneously. You only write per second when you talk about clock speed. Is correct. So we're going to say more cache memory means more frequently used data being stored, and hence a faster access than the slower RAM being used, and hence a faster access than the slower RAM, a faster access time, and this improves the performance of my computer. Clear? Okay, so what should I do with paper number 2? Do one yearly every day and try to practice as much as you can. Sir, I don't understand the role of cache. So cache is basically, we studied this even yesterday. Cache is basically one small component which is even faster than RAM. Okay, so I said that okay, when my CPU wants to talk, CPU is going to talk with the RAM. Why? Because your hard disk, that's very slow. It's very slow. So we said RAM is faster, so we grab data from hard disk into RAM. But then computer scientists came up with something even way more faster than RAM, which was cache memory. It is like even way more faster. But the only problem is that this is very small, and so it only stores the data which I am frequently using. Like every day I need to open up Google Chrome. So I would be like, okay, rather than wasting time on opening Google Chrome from RAM, I'm going to store it up here, so that every time I click on Google Chrome, it immediately loads up, saving the time, right? So cache memory is even way more faster, and this cache memory basically stores the frequently used stuff, frequently used instructions. So stuff which I do very commonly, all of that would be basically stored in that part, and you would be good to go. For any more questions about chapter number 3 components, we had a very good class yesterday and the day before too. You guys can watch those videos and everything would be clear in that. And if you need even more detail, the chapter number 3 playlist has been uploaded where every single component has been explained in one hour class. You can watch that and you'll be then good to go. Alright, moving on. So I guess we are done with it, if I am not wrong. Yep, we are done with it. So done with this. So done, and also done. Okay, this is also done. This is a chapter number 2 question where it says, okay, a question is up here in the paper which says that give the purpose of a router in the packet switching process. So if a question asks you for a process, asking about where does the router come in this packet switching process, you should know that the only sole purpose of a router is to basically ensure that it could control the route that the packet could take, or that it could efficiently select the route which should be taken, or like it could send each packet towards its correct description. Hence a faster occur. This basically means that if a task was originally being opened up, like if I wanted to open up something from the RAM and it took something like 2 seconds, because this cache memory is faster, it's going to take like 0.5 second up here. That's so great to know. C part is left for this question, sir. No, that C part is not relevant to this, what do we call it? question. It's from kidhar gaya? What question would we be doing? So yeah, so C part was from the memory part, so we're gonna do that inshallah tomorrow. Science roots, perfect. Alright, let's do the paper which Mustafa told us. So it's the May June 21 summer 21. Oh no, actually it's in March 21. Question paper 12, question number 8. Let's try doing this one question and then we can move on with ending the class because I'm cooked. Cache memory access data from hard disk or RAM? It basically, cache memory does not access data from hard disk or RAM. Your CPU needs to access the data either from RAM or from the cache memory. Either way, cache memory and RAM, both of them gets the data from hard disk. So the data comes from hard disk that goes into your RAM or goes into your cache memory. But getting the data from the cache memory to CPU takes less time, so the performance is better because it does not take 10 seconds, it only takes 3 seconds. But taking the data from the RAM to the CPU, let's say, takes 10 seconds, which is a lot of time. Okay, so question number 8. So okay, that's a good question. So let's try solving this question by Mustafa. He shared this question with us, and this is about the stored program concept. So remember, when we talk about stored program concept, this basically refers to that logic of von Neumann, where originally the previous computers did not have anything of nature where you could store the data. You were unable to store data at all. So you would like, okay, you plug in something, it would work. The moment you plug it out, it's going to stop working. So when von Neumann came in 1940, he brought up this concept of the stored program concept, where what happened was that you can now basically store the data. So your computers, all these computers which we have nowadays, they follow the stored program concept one, where instructions and the data, they are basically stored in the memory, and then these instructions are then fetched from the memory and then executed one after another. So you just have to write 2 points if ever this question comes up. You're going to say instructions and processes. So you can say instructions or perhaps data and data. So you see, like, all of these tasks, we have all the files, all the games, all the application installed. That's my data, and every time I run it, I do something on it. That's the instruction. Instruction is also stored on my program, on my hard disk, right? So I'm going to say that instruction and data, they are basically stored in the main memory, are stored in the main memory. And now, while they are in the main memory, what we need to understand is that my computer is going to basically grab the data, then it's going to grab the instruction, and then it's going to execute it using that. So I'm going to say the instructions are to be fetched and then executed one after another. So if I have multiple instructions, one by one I'm going to fetch an instruction. So instructions are to be fetched, are to be fetched and then executed one after another. Fetched and then executed one after another, and then executed one after another, one after another. That will get you a 2 by 2 up here. Part B now says that the fetch execute cycle of von Neumann model for a computer system uses registers and buses. Describe the role of program counter. Easy question. It stores what? A program counter basically carries, it basically stores the address of the next instruction. So it holds the address, or it stores the address. It stores the address of the next instruction to be of, it stores the address of the next instruction to be executed. Address of the next instruction to be fetched or executed. Instruction to be executed. To be executed. Perfect. And moving on, the next question now says that you need to basically explain the role of control bus. So control bus is something which basically sends signals to ensure that everything is synchronized and it works in the right way. So let's do this question. So what does a control bus do? What does this control bus do? So it carries the signals to ensure that the entire fetch execute cycle is synchronized. So yes, so I can say it carries command signals. So it carries control signals. It carries control signals from the CPU from the CPU to other parts of the computer, to other parts of the computer, synchronizing, ensuring that the fetch decode execute cycle, is synchronized. When I say synchronized, this basically means it's an order, everything is being done perfectly fine. Cycle is synchronized, which in simple words mean what? That it's in a specific order, that nothing is going here and there, everything is being done perfectly. सर फॉर द इनपुट आउटपुट डिवी की यार अपना दीवार में अपना सर में अब दीवार पे मारूंगा यार, मतलब ये कितनी दफ़ा पूछ लिया आप लोगों ने गाइस, बस कर दो यार प्लीज़. क्लास के बाद भी मुझे व्हाट्सएप पे मैसेजेस आ रहे हैं यार, इतना मैंने डिटेल में समझाया है, आप वीडियो देखो ताकि आपको समझ आए कि क्या आएगा एंड क्या नहीं आएगा. जस्ट गो टू द इनपुट आउटपुट पार्ट, वो जल्दी जल्दी देख लो एंड आपका हो जाएगा. भाई वर्किंग इज नॉट इंक्लूडेड एट ऑल. ओके, वर्किंग इज नॉट इंक्लूडेड, बट यू शुड नो वेयर इट कुड बी यूज, व्हाई इट शुड बी यूज देयर, हाउ इट माइट बी यूज देयर, क्या बेनिफिट है उसको इस तरह यूज़ करने का, वो सब आपको पता होना चाहिए. सही है. सो मतलब कोई बच्चा ये आके ना मुझे बोले कि सर आपने बोला था वर्किंग नहीं इंक्लूडेड, सो ये तो क्वेश्चन आ गया था कि बारकोड स्कैनर शॉपिंग मॉल में कैसे यूज़ होगा, तो सर ये तो वर्किंग आ गई. दिस इज़ इन वर्किंग, दिस इज़ द एप्लीकेशन. एप्लीकेशन के क्वेश्चंस आएंगे. वर्किंग का ये मतलब है कि ऐसा क्वेश्चन नहीं आ सकता कि बारकोड स्कैन होगा, सो द लेजर इज़ गोना गेट ऑन टू द बारकोड, इट्स गोना गेट रिफ्लेक्टेड, द कंप्यूटर इज़ गोना कन्वर्ट इट इनटू द ब्लैक लाइन्स एंड द वाइट लाइन्स, सो ब्लैक वुड बी 1, लाइट वुड बी 0 एंड सो ऑन. ये चीज़ नहीं आएगी. सही है. So when any question asks us for an output device in a certain scenario, and when I say screen, like not touch screen, I mean output is, we see display screen, you say the monitor. You say monitor. Monitor is the correct word. Or you can also say display screen, that's also fine. Or even if you want, you can also talk about LCD screen. Either of them works. So fetch, decode, execute cycle is basically a set of steps which basically executes an instruction from fetching it, getting it into the CPU and then processing it. Yeah. Shayan, I hope that question is good, वरना मैं मरा हुआ और फिर अच्छा नहीं होगा अगर वो boring सा सवाल आया कोई. सही है. Let's do this one last question on request of Shayan Asjad. And then, so it's question number 1. चलो कर लेते हैं भाई. Okay, so let's do this question. So the first question is from input output. So थोड़ा वो भी हो जाएगा. That's something good. So it says that a student uses a computer and several hardware devices to complete his schoolwork. The computer has a CPU and that the student uses a keyboard. So what's a keyboard? Keyboard is definitely an input device. It's an input device, so I'm going to say it's going to be input. So all the others are basically wrong because this is 100% wrong. This is, how can it be an output? It cannot be a storage either. Part B says that the student uses a printer to print his schoolwork. So what is a printer? A printer takes out data from my computer into into something physical. So if something like this happens, that is basically my output device. So that, therefore the answer is basically C, and we are done with this. So the next part of it says that a component in the CPU, let me paste it up. So yeah, so a component in the CPU sends signals to manage the fetch, decode, execute cycle. What is that component? So in your syllabus, remember that whenever we were just discussing this part, whenever a question comes up that asks you in regards of how you can basically send control signals, so it's our CEO by which is our control unit. And then it says the clock speed has a speed of 2.4 gigahertz. We just did this. This basically means that there are basically 2.4 billion fetch, decode, execute cycles performed per second. Okay, so you need to write that. That's everything you need to write. Or you can also say clock fetch, decode, execute cycles. You need to write cycles or pulses. Okay, so the word cycles is important. Moving on, the next question up here says that you need to basically describe the role of what? Let me paste it. So it says the CPU contains registers including the MDR. Describe the role of MDR in the fetch, decode, execute cycle. Bro, this wasn't a difficult question. This was an easy question. So what does the MDR do? MDR basically stores the data which has been fetched to basically read from the memory, or maybe it stores the address where I have to write in the memory, right? So you just say that it basically stores the data, stores data which has been, this is like the basic definition of MDR, which has been read slash which has been read, or like you can say that has been which has been fetched कर दो, stores data which has been fetched to read or write data in memory. So stores data which has been fetched to read or write to into the memory. Okay, my laptop at this point is literally, I don't know what happened to it, but yeah, into the memory. And doing this will basically get you 2 by 2. And then it says identify 3 other registers. We just did this, man. Just this. So it basically you have a lot of, so you can talk about accumulator, you can talk about program counter, and you can talk about, let's say, MAR, because it said other. So if you wrote something like MDR up here, you will not be getting marks. So please guys, don't be making such mistakes. Be a bit vigilant with the fact that is something they mentioned that this is apart from this, तो उसके बगैर ही करना है, वो point ना लिख देना please. So this wasn't a difficult question at all. It was a pretty straightforward, but I hope Shayan it got answered. So what is clock speed in simple words? Clock speed is the number of fetch, decode, execute cycles performed every second. So the number of cycles, the number of executions that happen per second, that is known as the clock speed. So the greater the clock speed, the greater the number of fetch, decode, execute cycles that will be performed per second. But yeah, that is it for chapter number 3.1. We did not get a lot of chapter number 3.2 questions, but we did both 3.1 and 3.2. We're going to start off from 3.2 plus 3.3 and 3.4. We're going to do this set tomorrow again, inshallah. We're going to see if we had time, we might do some chapter number 4 questions too. So that's it for today. Again, the class tomorrow will be at so tomorrow's class is most probably going to be at, let's keep it at the same 4 to 6 p.m. okay, so that's the timing for tomorrow's class. We're going to do chapter number 4 and chapter number 3 complete, inshallah. According to me, what is that one mistake a lot of students do? So not reading the question carefully and writing vague stuff. You need to be pretty much very direct. You need to be very much precise. Don't write random stuff which isn't, being tested and all that stuff. So writing such stuff won't help at all. Chapter number 4 would be done tomorrow. 5 and 6 will be then, inshallah, done on the next day, 12th. Paper is on 13th. But yeah, that is it for today, everybody. I hope the class was lovely and that you learned something, and that questions थोड़े बहुत clear हो गए from chapter 3 and chapter number 2. But inshallah, see you guys tomorrow. Take care, everybody. Allah Hafiz. बस दुआओं